Here's another example of a percent yield question that you may be asked. Okay, suppose that 4.950 kilograms of ammonia gas is available. What mass of ammonium nitrate will be produced using that gas if the reaction is known to only have a percent yield of 89.5%? Okay, in other words, it's 89.5% efficient. Okay, here we go, and they give us the equation. The equation for the synthesis of ammonium nitrate is as follows. There it is. This one's pretty easy. It's got a 1:1:1 ratio for all of the elements in the equation. So, let's get started with this one. So first of all, the molar mass of ammonia is equal to, so for nitrogen, 14.01 plus 3 times 1.01 grams per mole. This starts out as a stoichiometry type question. And so the molar mass in total is 17.04 grams per mole. Okay, so so there we have it. So trying to find the number of moles that we have to start with, number of moles of ammonia is going to be the mass of ammonia that we have divided by the molar mass, and then we can start plugging those moles into our equation. Okay, so we'll go 4.950 kilograms. Better convert it to grams, so we'll multiply that by 1,000 grams per kilogram. That gives us our mass, and we'll divide that by the 17.04 grams per mole. Okay, and that works out so that for ammonia you end up with 290.49 moles. Okay, so we have 290.49 moles of ammonia, and the question is talking about the amount of ammonium nitrate that is produced. Okay, so let's do basically stoichiometric ratios, a calculation to find out how many moles of ammonium nitrate should be created theoretically using this 290.49 moles. Okay, so number of moles of NH4NO3, number of moles of ammonium nitrate that should be produced will be 290.49 moles times, and the ratio is 1/1. Normally that would be it. That would be it. We've got 290 moles of the ammonia. We're trying to find how many moles of the ammonium nitrate is produced. It's a 1:1 ratio, but as this reaction is going forward, we have to realize that some is being lost because there's a percent yield involved. What was that percent yield? It was 89.5%. So only 89.5% is actually making it from the left to the right side of this equation. So in this calculation line here, what I'm going to do, instead of just multiplying by the molar ratio, I'm also going to multiply by 0.895, our percent yield. I've taken it and I've divided by 100. 89.5 divided by 100 gives me 0.895, and I'm going to multiply by that. That's how many moles are actually yielded of the ammonium nitrate. Okay, so that works out to be 259.99 moles. I'm carrying more significant digits than I really need to at this point, but that's okay. More is better until we get to the very end. Okay, so since we have that many moles, we just quickly convert over to mass. Now to complete this question, we find the mass of ammonium nitrate is the number of moles times the molar mass okay, and grams per mole. when we multiply that through, or when we add things up, this many moles times molar mass for the compound of 80.06 grams per mole, and we're left with 20,814 grams, which we can convert to 20.8 kilograms, rounding it to 3 significant digits, which is what this question called for.